For the extra practice on this section, I just want to go back and review the first couple of steps before you do any of these problems. Step 1 is always to remove anything near the absolute value. And if I notice on this problem, there is nothing near the absolute value, so step 1 is already done. Step 2, just like absolute value equations, is to set up the positive and negative solution sets. And then the new step for each of these is determining if this is a and or an or statement. And the way that I remembered these is I think less than or great or. And those are our 3 steps for solving all of these problems. And the nice thing is that even if you're going to get a strange solution, like every value works or no value works, you can still solve them the same way. So for this problem, we have a greater than symbol here, so it is a great or than. I'm going to do 2x plus 2 is greater than 4 as my positive solution side. My negative solution side will be 2x plus 2 is less than, because I am going to multiply this side by a negative 1. And because I multiplied by a negative 1, I must flip the sign. From here, I'm going to solve my equations like I've done many, many times up to this point. So I get 1x is greater than 1, or from here, I'm subtracting 2 again, and I get 2x is less than a negative 6, or x is less than negative 3, with an or statement between them. So if I shade 1 with an open circle, I'm going to shade to the right, and negative 3, here I'm going to shade to the left. And that is the entire problem. They get harder than this in terms of numbers, but the strategy will always be the same. For this problem, we have to get rid of the negative 4 before we can set up the positive and negative solutions. So I'm going to divide both sides by negative 4. And one of the tricky parts here is to remember that I need to flip the sign here, even though I haven't yet set up the positive and negative solution sets, because dividing by a negative flips the sign. Now that I have these alone, I can set up the equation, and now it is a less than symbol, so it is less than. So we have an and statement between them, and I can set up my problem. So I have 3x plus 2 is less than 4, and on the right side I have 3x plus 2 is greater than negative 4, remembering to flip the sign again. A very common mistake is to do the less than or greater right away instead of waiting until right before you do the positive and negative solution sets like we did in this problem. Now I'm going to solve my equations, which I've done many, many times before. I'm sure you are not sick of this at all, even a little bit. And then I'm going to subtract 2 from both sides to get 3x is greater than negative 6, dividing both sides by 3 to get x is greater than negative 2. To shade these problems, 2/3 is right about there. It is an open circle. Negative 2 is right there, also an open circle. We're shading smaller than this number, but bigger than this number, which means we are shading between them for this problem. We have one left. For this problem, we have multiple steps to do before we can set up the positive and negative solutions. I notice right away that I have 4 minus 4, in making sure we're looking at the number in front. So I get 2 absolute value of 5x plus 2 is greater than or equal to 0. So I see a 0 here that's a little bit different. I got to keep my eyes open because it's likely that this problem's going to throw us a small wrench here. So I get the absolute value of 5x plus 2 is greater than or equal to still 0. Now I can still set up my positive and negative solutions here, but I should be well aware that something weird might be happening because we don't normally have a 0 on our inequality symbol. So I have right here, by the way, this is greater than, so it is an or statement. So I'm going to do 5x plus 2 is greater than or equal to 0. And on the other side, I'm going to do 5x plus 2 is less than or equal to negative 0, which we remember is just 0. So once again, I see something weird is going to happen here. We're not sure where yet. But after I solve my equation, I get 5x is greater than or equal to negative 2. And x is greater than or equal to negative 2/5. On the right side, I'm going to get the exact same thing, except that it's less than or equal to negative 2/5. So before we even graph this, I just want to think about x is any number that is either smaller than this number or bigger than this number, and it can be equal to that number. It sounds like to me that it's probably everything. There's probably no number that doesn't fit these requirements because it's an or statement. But let's graph it just to double check. Negative 2/5, that's the same as negative 4/10 as a decimal, which is right about there with a closed circle. This side is going to have me shade bigger than the number. And this side is going to have me shade smaller than the number. And it looks like to me every single number is filled in here. So we're going to say that x can be any real number. And that is the final section on solving equations and inequalities. As always, if you have any questions, please let me know.